Welcome to Let's Talk Cancer. I'm Kerry Adams, the CEO of the Union for International Cancer Control, and today we have a truly out-of-this-world episode for you. The intersection of cancer and space may seem like an unlikely pairing, but it's a frontier where groundbreaking discoveries are being made. Joining us today is Peggy Whitson, America's most experienced astronaut, who worked with NASA before serving as commander on the Axiom Mission 2, the second all-private astronaut mission to the International Space Station. Our second guest is Catriona Jamieson, director of the UC San Diego Sanford Stem Cell Institute. Both are working on cancer in low Earth orbit, an experiment to study prospective therapies for colorectal and breast cancers by testing countermeasure drugs on the International Space Station. Join us as we journey to the frontiers of knowledge and explore how, in the vastness of space, we may find new answers to one of humanity's greatest challenges, cancer. Welcome to this podcast, and thank you very much for giving us your time. Peggy, perhaps I could start with you. So how do you conduct research in space then? I mean, how does it actually work? What's the practicalities of it? And, we see images of people in space and it looks quite difficult just to have a drink. So how do you do that?
It's challenging. There's lots of different challenges of working in space. It offers a lot of unique environments that you don't have to worry about. Like, for instance, on the ground, you have convective forces, you have sedimentation forces. And up in space, you don't have any of those things impacting you, which is an advantage for a lot of different studies. Obviously, no gravity either, so things can float. But disadvantages are you end up having bubble formations because cohesion is that surface tension tends to cause a little bit more problems with fluids and things. And so sometimes the hardware has to be modified to accept that kind of work in space. And so it's just an adaptation to living in space and working in space there. So as a scientist, it's a lot of fun for me because you have to learn different ways of doing things. In order to hold my samples down, I have to have Velcro or sticky sided tape with sticky side up. Just lots of different techniques that we use to try and adapt to working in that environment. So I like the challenge, and it's a lot of fun for me.
So what unique insights can we gain from conducting cancer research in space?
Well, we've actually found over the years that cancer cells tend to grow a little bit more like they do in your body without the effects of gravity on them. A lot of times they will actually grow and form more like they do in your body, which we have a hard time replicating for certain types of cancers on the ground. And so it's a good model system to test things like drugs or therapies that we might be able to use on cancers. And so that's one of the main reasons that we like to do it.
Okay, maybe I could turn to you then. So the Cancer in Low Earth Orbit project is, I understand, groundbreaking as an initiative. So can you provide some sort of overview what the project is and why you believe it's so significant for cancer research?
Well, you use the term groundbreaking. I use the term space breaking. Cancer is a problem because it decides to invade and go forth and multiply. And this is what space recapitulates. That stress of microgravity allows cancer to do this even more quickly when we get into that low Earth orbit environment than it happens on the ground. It just happens faster. So what gave us insights into thinking about this was actually the seminal NASA twin study, where Scott Kelly spent 340 days in space, but he came back with pre-leukemic inversions and translocations in his chromosomes, and also telomere changes that made us think, wait, those are pre-malignant changes. We wonder if we send full-blown cancer into space in a tumor organoid system, whether or not we'll see enhanced proliferation, which indeed we did with the Axiom 1 mission. And then we said, well, that's too Debbie Downer to just leave it at that. We better see if there are countermeasures or ways to predict, prevent, and possibly reverse that. And that's where Peggy helped us make this seminal discovery that we can predict, prevent, and reverse cancer's cloning capacity in space.
So, Kat, can I just clarify the relationship between the two of you? So, Peggy, you're the one that goes into space, and Kat, you're the one that stays down on the ground. Is that right?
Yes.
Excellent.
Yes,
okay.
Thank you.
So you're a team.
Thankfully.
You're a great team. Yeah.
We're a team.
Right. Right. I'm Kat's hands.
I think you're so much more than that, Peggy.
I really am her hands, and when I'm on orbit and I can display and collect the data the way she wants it to be seen.
This was an incredible partnership that we were very fortunate to forge thanks to NASA and their prescient notion that we really need to understand cancer development under conditions of stress and how aging plays a part in that, and that we need to have these unique partnerships. So we developed a little pediatric blood bag that had tumor organoids that Peggy could help us to image on the microscope in low Earth orbit. And then we have the ground control. So Peggy and I are complete partners. When she's doing the experiments on orbit, we're doing them on the ground. And what Peggy showed us is this has really important ramifications on Earth. By accelerating the time frame for cancer development, Peggy was able to catch in one moment that cancer runs for cover when we give cancer this drug called rebexinib, and that's an inhibitor of a molecule called ADAR1. That ADAR1 is the cancer cloning gene, and it gets turned on like gangbusters. It blasts off in space, and it's really, really important to do that because it helps our therapeutics development on Earth. It accelerates it. And that's the advantage of working in these extreme environments. It recapitulates years worth of stress, but compresses it into this very short period of time so we can accelerate the process of therapeutics development.
I love the phrase, cancer runs for cover. Okay. So the experiments you're doing in space help you accelerate the research. So how do you translate that into what you're doing on the ground?
I think when you have a stellar scientist, pun intended, like Peggy Whitson, showing that this matters, that generates a lot of interest. And especially with my patients, I'm also a practicing hematologist. And they say, what is this in space? Why is NASA helping us? I said, well, you have the smartest people in the world and out of this world helping you with, as you alluded to, one of the toughest problems on Earth. Cancer is the number 2 cause of death in the U.S. and is a major cause of morbidity and mortality internationally. It's about time we understood how cancer really gains hold, how it blasts off.
So all of that combined energy and the ability for you to work together really well, has that led to any discoveries? You mentioned about new drugs there, Kat. Where do you hope this is going to go in terms of new discoveries? Because from a cancer control perspective, we love it when we hear there's new ways of understanding how a cancer develops and how it can be stopped. So where are you on that spectrum at the moment?
What I learned in going to my first launch at the Kennedy Space Center was that rockets need rocket fuel, but they also need liquid oxygen to really boost to get off the ground. And what we find with cancer is that there's rocket fuel and there's an enzyme called ApoBec3 that seems to be the rocket fuel to initiate pre-cancer. And then the liquid oxygen equivalent is that ADAR gene, that cancer cloning gene that I mentioned, that really allows these cancers to blast off, invade, and spread or metastasize to other sites. So what we discovered together with the Axiom crew and Peggy in particular is that cancer cloning gene, when we use a genetic reporter for that gene, gets turned on. It turns on that green fluorescent protein, but also that becomes a therapeutic vulnerability or Achilles heel. So by understanding that's a main driver of cancer proliferation in space, particularly in these triple-negative breast cancer models, we were able to add 2 drugs. One is called fedratinib. It's FDA approved, and that seems to block the inflammatory growth factor-induced activation of ADAR. The other one, rebexinib, really more selectively blocks ADAR by preventing malignant splicing, and that one seemed to be the more potent one. So the reason that advances therapeutics development, it says that what we have now that's already FDA approved is probably not going to be good enough. The one that we need to make is rebexinib to really get after tumors, and there are about 20 different tumors that rely on ADAR to be their liquid oxygen to really allow them to blast off. That compels us to make rebexinib as a drug, but it also caught the attention of grant reviewers who felt equally compelled and said, okay, well, we think you should make that drug.
Peggy, it was mentioned earlier, I think Kat mentioned about an astronaut who's showed signs of cancer on return. Can I just switch to the challenges of being an astronaut? Peggy, you've been in space how many days? You told me earlier, how much was it?
675 days.
In the future, that could be a lot longer for many others.
Absolutely.
Yeah. And is there a greater likelihood of you and others of developing cancer as a result of the trips that you make?
Well, we obviously live in a higher radiation environment when we go into space. And so that has the potential, obviously, to contribute to cancer forming. The other thing that Kat also mentioned was that we have what a lot of people feel is accelerated aging. And so obviously, as we age, we're more likely to express cancers or have them be expressed within our bodies. And so I think both of those are probably the biggest contributors for that potential of having more cancer.
The challenge, I guess, is monitoring health during that period. And if cancer is accelerated and aging is accelerated, then there's a greater risk for cancer with longer space travel. So anything that you as an astronaut are doing in order to really protect your health, avoid the risk factors for cancer, for example?
Well, the one thing that we also have a diet that's much lower salt to try and protect, for instance, bone demineralization processes. Once we know a little bit more about what we can do to minimize for cancers, I'm sure that those types of therapies will also be included. We do try and use radiation shielding in our vehicle to protect from the radiation events. But as Kat mentioned, there's lots of stressors of being in space, and everyone's body reacts just a little bit different.
Is that something that your research is going to help as well, Kat? Is that going to help astronauts like Peggy survive the potential higher risk of cancer as they spend longer in space?
Yeah, so what I should say is there is a lot of inter-individual variability in terms of response to space, but response to stress in general. We actually respond differently from a stem cell standpoint to the same stress. So the three of us may experience the same stress, and some of us will mobilize our stem cells and other ones won't. So we're trying to understand that first and foremost. But the bioreactors, these little pediatric blood bags with a three-dimensional sponge that we seeded normal stem cells into, have this fluorescent reporter, a genetic reporter, and really understand this in real time with real-time imaging as the canary in the coal mine for each astronaut as they go into space. So we can say, Peggy, your bioreactor is telling us that you're getting a bit stressed up there. You may need to shorten this mission. And so that's what we're trying to give back to the astronaut community. It's not just to NASA, it's to the very bravest, best scientists that I've ever met who are going to be heroic and take on these fundamental challenges for humanity and do it themselves. I'm not brave enough to do that, and I get motion sickness, so I don't think I'm going to be doing this anytime soon. But these are remarkable insights that we could never have got. So that canary in a coal mine, my dad was a coal mining engineer, so I'm a coal miner's daughter, is something my dad talked about. Canaries will die with carbon monoxide exposure. You can't smell it. It's the same thing with space. You don't know that you're being exposed to something. So that's what we can give back. The nanobioreactors have value, and they would be the little mini avatars for each astronaut. But we can do that on the ground as well.
Peggy, you don't strike me as someone who's going to be stressed when you're in space. I mean, but I may be wrong. But what's your involvement? What's your interest in this research? I mean, you must have a very keen interest in the medical advances that can derive from the experiments that you're doing and helping Kat on the ground. So where did your interest come in this?
Well, over the 2 decades that I've been an astronaut, I've seen lots of different investigations happening in space. And there's some really exciting finds that we are seeing up there in space. But obviously, everyone wants to help cure cancer. And so there's a big push in my mind to try and help out as much as we can. From my perspective at Axiom Station, in the future, when we start building Axiom Station connected, at least initially, to the International Space Station, we will have even more potential to help commercialize activities that occur in space. Right now, it's basic research that's been going on, and Axiom Space has the goal to actually take all that research to the next level and actually maybe produce things that we need here on the ground. I really see the future being an expansion of pharmaceuticals that were made in space. And, Kat's research has already shown us one particular pharmaceutical that may be a big factor in fighting those cancers that all of us care about.
And in terms of the therapies that, Kat, you're looking at, breast cancer is a particular target. Are there others where you feel that there is more opportunity for new therapies coming out for cancers, or is it a broad learning which is applicable to many cancers?
I think it's a broad learning. I think this is applicable to many cancers. When you take that gene ADAR1, ADAR is on our radar. It's activated in 20 different malignancies as they become resistant to therapy and decide to clone themselves and evade host immune system responses. So it's sort of like the cloaking shield that the Klingons had. That's what ADAR does, is it allows cancers to evade and sneak past the human immune system. I think that the key here is really starting at pre-cancer. Really not waiting until cancer is blasting off. And this helps everyone on the ground. So the Axiom 2 crew has been extremely thoughtful to be part of this research. Approved research where we collect blood stem cells before launch, launch minus 45 days, launch minus 1, during flight, launch, after return, day plus 1, and then day plus about 45 to 54, and then yearly. So that we can not just see, pre-cancer or cancer developed, stop it in its tracks. Again, make cancer run for cover. Don't allow it to take over. And that's how the astronauts are helping with our attempts to stop cancer when it's at the pre-cancer stage, or even before that, when we see accelerated hematopoietic or blood stem cell aging and the immune system isn't being made properly. Well, that's how cancer gets an upper hand. We need to say to the immune system, wake up, smell the coffee. You really need to be on this. And that's why patients are so encouraged. I see patients in my clinic with a pre-malignant condition called a myeloproliferative neoplasm or disorder. And that's where we can intercede. We need to get at cancer before it really gains hold. And that's where these really important missions with Peggy and the Axiom crew have been absolutely vital, and with NASA really helping us to understand a new frontier for unraveling cancer development in its very earliest stages. And that's why this is so important.
Kat, a lot of that depends on the ability to diagnose early. And I know that diagnosis can be expensive, difficult, complicated, and available to the few. So are you optimistic that diagnosis can progress as a result of this research?
Absolutely. So in terms of diagnostics, we're developing stem cell fitness tests and really trying to have a pre-cancer atlas that we develop that's stem cell specific. Because if you get a mutation in your stem cells, those stem cells last our lifespan. That's why the stem cells matter. They have inherent longevity. So it means if you have a cell that has precancerous mutations and it can last 80 years, you better know about that. That's the cell you need to target. So we are developing more enhanced diagnostic capacities, not just for people to prevent them from developing cancer, but for people who have already had cancer and they're worried about the cancer coming back. So the number one cause of death due to cancer is cancer recurrence, not the initial diagnosis. So this is going to help us to have early warning signs, radar, for cancer recurrence.
And Peggy, is there any way in which you can replicate the situation or circumstances in a space station on Earth? Is there any way you can do that? Or is it a unique place where you can do things differently?
It is a very unique place, but sometimes once we understand what part of the microgravity environment changes something, we can change activities of things and understand them better, and then refine the processes on the ground to try and compensate. One in particular is protein crystallization goes very well in space. And by understanding, the conditions that we are generating in space, we can sometimes mimic or reproduce some of those characteristics here on the ground. And so sometimes it's an understanding that enables us to improve our procedures and process on the ground. And other times it is wholly a unique environment that can't be reproduced on the ground.
Peggy, can I ask, Are there other experiments taking place with regard to other diseases? The UICC, my own organisation, works in partnership with, for example, the diabetes groups, the heart groups, heart disease groups, the lung disease groups, because we have common risk factors. So are there other experiments in that space as well?
Absolutely. We've done cardiac stem cells, grown them in space, and done various research on that. We've done a lot in particular in bone studies, because it's another particular environment where space accelerates bone demineralization on the ground. For instance, a osteoporotic woman would lose 1% of her bone density in a year. And in space, we would lose 1% of our bone density in a month if we did not compensate for it with exercise, 2 hours worth of exercise a day. So it's a great environment to test therapies, new drugs. We've used rodent models. We've used cell culture models to look at new drugs and different types of therapies in that area as well. So there are lots of venues where space offers an advantage, and it just requires some of that basic research to be completed, and then to take it the next steps, much as Kat's team is doing.
I'm so glad that we've got you two leading the way, developing the opportunity to find discoveries. Not groundbreaking, Kat. I took the nod. It's space breaking. I can understand that. Thank you very much. That has been really very interesting. I hope that inspires the cancer community and those who listen to this podcast, because we want to hear about these great new ideas, innovative ways of identifying new medications. And I certainly love the phrase that you used, Kat, about the cancer runs for cover. Let's hope that it does with the work that you do and the outcomes of that work. So thank you very much, both of you, for the work you're doing. It really is appreciated.
Thank you.
Thank you very much.
Thank you for listening to Let's Talk Cancer. We hope you enjoyed this episode. If you have a moment, please do give us a rating and share the podcast. It really helps us reach a wider audience and inform more people about issues surrounding cancer. For questions and comments, don't hesitate to get in touch at communications@uicc.org.